integrals. For integral secant power m of x times tangent power n of x dx. Okay, so yesterday we did sine cos, now we do secant tangents. Okay, so again, there's a few cases. So case 1. Okay, and that's when m is even. Okay, so example.
Is this considered trig step substitution?
No, not yet.
Okay.
But it's the last trig integrals that we're going to do before going to trig substitution.
Okay.
So when you do trig substitution, you might, after the substitution, end up with an integral of this form. Okay, that's why. So let's see, m is even. So integral of, let's say, secant 4 of x times tangent. So tangent could be anything, either even or odd, you don't care. So let's say power 7, I don't care, okay, of x dx. Okay, so you have to remember just one identity here. And the identity that you have to remember is that the 1 plus the tangent squared of x is equal to the secant squared of x. Okay, so this one you have to remember. Okay, so this is equal to integral. So now I'm going to save a secant squared, I'm going to bring with the dx. So secant squared x times tangent 7x times secant squared x dx. Okay, then secant squared, I know, I just wrote it here, that secant squared is 1 plus tangent squared. So this is the integral of 1 plus tangent squared x times tangent 7x times secant squared x dx. Okay, and now I could do a substitution. Substitution will be u is equal to tangent x, and so du is the derivative of tangent is secant squared x. Okay, it's perfect, very convenient. That's why I saved the secant squared here. Okay, that's going to be my du. Okay. So that's why this works only if m is even, because that guarantees that if I pull out a secant squared, I'm left with an even power of secant, and that will allow me to use the identity here. Okay, if I had secant cubed here, I'd be stuck. I couldn't use there. There would be an outstanding secant. Okay. So I have the integral of 1 plus u squared times u7 and secant squared x dx, which is d. And that's an easy integral again. Okay, so it's u7, so the antiderivative of u7 is u8 over 8, plus this is u9, the antiderivative is u10 over 10 using the power rule. And that's it. And now I replace u back by tangent and I'm done. Tangent 8x over 8 plus tangent 10x over 10 and plus x. Case 2. Okay, so we did when the secant is even. Now what happens when the tangent is odd? Okay, so when n is odd. Okay, so example, the antiderivative of so secant 3 times tangent secant 3x times tangent cube x dx. Okay, so what I'm going to do now is I'm going to extract a secant and a tangent. So secant squared x tangent squared x times, and now one secant and one tangent. Secant x tangent x dx. Okay, I extract the secant tangent. That means that I'm guessing that I'm going to use u equals secant, because the derivative of secant is secant tangent. So secant squared x times, and tangent squared is what? Tangent squared is secant squared minus 1 times secant x tangent x dx. Okay, and now I'm ready to do a substitution. It's a very easy one. U equals secant, and that's my d. So u equals secant x. So du is secant x times tangent x times dx. Squared times u squared minus 1 times secant tangent dx, that's du. And that's it. So u4, the antiderivative of u4 is u5 over 5 minus u2, whose antiderivative is u3 over 3, and plus c. And then I replace the u back by secant, and I'm done. So secant 5x over 5 minus secant 3x over 3 plus c, and that's my answer for the second case. That's how it works. So case 3, last case, is so if m is odd and n is even. Okay, so in these cases, there's no real technique. Okay, so these are the harder ones, and each one is its own little problem. Okay, so you have to really, this is survival mode for this one. Okay, so there's no trick. So I'm going to give you one example. But if on the test you see a case where you have m odd and n even, you're probably going to have to struggle a bit. Okay, that's a challenging one. Okay, so let me give you an example. So a good example would be the integral of secant, right? Just secant, right? M is odd, n is even. There's no tangent, and you know the integral of secant. We did together. You had to multiply by secant plus tangent, secant plus. Remember, right? We got ln of secant plus tangent. It was a bit more complicated. Let's try secant cubed. Okay, so you'll see that this is a tough one. Okay, So it's equal to, so let me call this integral. I'm going to call it I. Okay, the integral I is, okay, I'm going to call it like this. This integral is what? The integral of, so secant cubed, it's going to be secant times secant squared dx.
Is it I in front? Like
That
I?
is I for integral, okay, the integral I.
Okay.
You'll see why in a minute. And this integral now, I have a multiplication. I'm going to use integration by parts. So I will do u is secant, and dv will be secant squared x dx. Why did I partition it this way? Because the integral, the antiderivative of secant squared, I know. That's an easy one. That's the antiderivative of secant squared. We know that it's tangent. Okay? And du, the derivative of secant, is secant x tangent x dx. Okay, and I'm going to take it from here now. So I is equal to what? My integral here is equal to what? uv secant x tangent x minus the integral of v times du, which is secant x times tangent squared x dx. So far, so good? Okay. But tangent squared, we know from here that tangent squared is equal to secant squared minus 1. So I'm going to replace it here. So secant x tangent x minus the integral of secant x times secant squared x minus 1 dx.
So I have a question.
Sure.
Why didn't we just replace 6 square with 1 plus 10 square x at the beginning?
Here?
Yeah.
And then what?
Use substitution.
Do substitution. What do you take as a u? Sorry?
That wouldn't work.
It wouldn't work because you need a secant squared. The secant is going to be annoying.
Yeah.
Okay.
Okay.
But it's good. But it's very good. You have to try it. There's no choice. Okay, and maybe it would lead you somewhere. Okay. So until here, we okay? Let's continue up here. So I is equal to secant x tangent x minus, and here I'm going to multiply everything inside here on the bottom. I will have integral of secant cubed x dx plus, right, plus the integral of secant.
So it's cubed, not squared.
Excuse me?
This
This is cubed, sorry. You're right. I said cubed, I wrote squared.
Wait, so it's plus because you factored the minus?
Yeah, because of this minus here on the bottom.
Okay.
I just realized you don't see my hand when I point. All right, so I is equal to secant x tangent x minus, well, this is I also, right? This is also I. Right? The integral of secant cubed is I. So I could write it I. And plus the integral of secant, you remember that one? We proved it. It was ln of secant x plus tangent x. Okay, this we did it.
Sir,
Yep.
to get this on the test, like the integral of secant x, do we straight away put ln secant x plus tan x, or do we have to prove it?
No, it's okay. So this, since we proved it in class, you could use this. Okay, you could reuse it.
Okay, perfect. Thank you.
Okay, and then so now I'm going to send the I on the left side. So 2I is equal to secant x tangent x plus ln of secant x plus tangent x. And so I is just 1/2 of all this. 1/2 times secant x tangent x plus ln of secant x plus tangent x and plus